All right. How's everyone doing? Good to hear it. Let's look at let's look at this task. I'm going to walk you through some things, and this will set us up for tomorrow. So if this is a little confusing now, don't worry because we had another day to dive into it. So this is just going to hopefully make tomorrow easier when we really try to think it through. But for now, let's start with number one. I know it says it's homework, but we're going to do the assignment, and then I won't assign the homework. We'll have to check your understanding problems, but enough blabbering. An explicit rule for a sequence 2n minus 5, where the n is the term number. Find the first four terms of the sequence. What that just means is if there's terms 1, 2, 3, 4, then what is this? What goes here? What goes here? What goes here? Well, just plug the term. N is the term number, so plug 1 in there, and then plug 2 in there. Whatever you get goes there. That'd be the first term, the first four terms of the sequence. And then you're going to plug in 3 for n. So you do 2 times 3 minus 5. So that's 6 minus 5. That's 1. So I already told you what that third one's going to be. And then 4, same thing. Plug in 4. That's what it's saying. It's easier than you think. It's just understanding what it's asking. So usually when we're talking about all these sequences, we got term 1, term 2, term 3. Sometimes we have term 0, and we'll get to that. But number 2, this one's pretty straightforward. The cost of a family gym membership depends on the number of family members joining. The monthly cost is $15 service charge, plus it's $10 per family member. So one family member, it's $10, but you have the $15. So two family members would be 10 plus 10, or 10 times 2, plus the $15 service charge, right? So whatever goes there, whatever goes there, whatever goes there. 4 family members would obviously be $40 plus the 15, right? So 55. It says write an explicit rule for n family members. So this should kind of ring a bell from last year. So for n family members, well, it's going to be $10 per family member. So it's 10 times how many families? 10 times n, or what we would say is 10n. Plus, you've got to add the $15 service charge. $15 is just one-time fee. It's not per family member. And that would equal the total monthly cost, or T, or C, whatever letter you want to do. All right, let's look at number 3. Leanne and Vincent are each looking at a sequence from their homework. Leanne describes it by saying that sequence starts with 6, and then you add 10 repeatedly. Vincent says the explicit formula for the sequence is -4 plus 10n. Are Leanne and Vincent looking at the same sequence? Explain. Well, here is the verbal description. It starts with 6, and then you add 10 repeatedly. So if we want to, let's write that sequence. We start with 6, right? Or maybe we should say the first term is 6. The second term is, we add 10 repeatedly, is 16. Then third would be 26, and so forth. So there are the first 3 terms, right? Now Vincent says the formula is -4 plus 10n. So we could, just like number 1, take this 1 and plug it in for that n. In other words, 10 times 1 is 10, plus a -4, which is 10 minus 4, which is 6. So far, that is the same sequence that Leanne just described her. Well, let's try number 2. Let's plug in 2, where it says n. 10 times 2, 20. 20 minus 4 is 16. Guess what? They describe the exact same sequence. Are they looking at the same sequence? Yes, because their description and formula both give the same numbers. You can write that down. You can pause this if you need to. Either way, let's look at number 4 when you're ready. The first 5 terms are shown in the graph. 1, 2, 3, 4. There's the first 5 terms. Here's term 1, 2, 3, 4, and 5. Describe your sequence in words. Well, what is happening there? It looks like term 1 is at 11. Term 2 is at 7. You might even want to write this down. Term 1 is at 11. Term 2 is at 7. Terms 3 is at something. Terms 4 and 5. And you're probably going to notice something. So what is happening? Go ahead and describe what that would be. What would be the 6th term? Well, I bet you could figure that out once you figure out that one. Then it says write an explicit formula. This is something we'll talk about more tomorrow. On Thursday, but long story short, write an explicit formula to find the nth term, right? You're going to notice, well, if you didn't notice already, it keeps going down by 4, right? So we might want to say like it's going down 4, but is that like, is it just minus 4? Like, that's it? But is it minus 4 times n times term? Usually that's kind of on the right track, but we also have to have like a starting point, right? Like up here, there's this starting point, believe it or not, was kind of at -5, right? Here, our starting point was kind of at 15. Right here, our starting point, we didn't know this, but it's kind of at -4. Even though our starting point was at 6, technically our starting point would have been -4 because 10 times 0, if I would have plugged in 0, right? So we can start at 0. A formula can start at 0, or a formula can start at 1, but I'm going to kind of leave this one out in the air because there's some chance that maybe I'm going to want us to do this in our groups because it's good thinking. But what do you think? What number would work here? Could we try writing 11 there? Is the formula 11 minus 4n? Well, if we put in the first term, we put in 1 here, that's 11 minus 4, because that'd be 11 minus 4 times 1. That'd be 11 minus 4, which is equal to 7. And our first term is not 7. It's actually 11. Our second term is actually 7. So what could we do to this formula to make it work? We don't want that to necessarily be n. It's a subtle position, but you don't want this to be n. You kind of want it to be something else. Do you want to add 1 to that? N, if the first term, that'd be 2. Or no, I don't know if you want to add 1, but maybe we want to take away 1. We want to be 1 less term. So if term 2, if I plug that in here, by the way, I can get rid of this box because now I'm talking about this whole formula here, 11 minus 4 times n minus 1. This sounds complicated, but I'm trying to figure out how these terms could work. And if you notice, if I plug in 2 here, 2 minus 1 is 1. -4 times 1 is -4. 11 minus 4 is 7, which is exactly where term 2 is at. We'll talk about that more. We'll see some more problems, but if that's the meat of this unit, so to speak, or at least up to right now. So here's something we're going to learn more on the next day, but it's saying explicit rule for the sequence. What does explicit rule mean? That means, if you look here, it says Twyla is attempting to write an explicit rule for the following sequence so that she can find the nth term, 9, 24, 39, 54. She says, well, it starts with 9 and we add 15 repeated. She is right, but that's not an explicit rule. We'll learn more, or I'll tell you right now, an explicit rule means you're going to write a formula or an expression or an equation that has the nth term in it. Whoa, that's horrible spelling. The nth term. So in other words, what is happening here? Is she going, is this n plus 15 times n? Like, that's technically an explicit rule. But I don't think that works, because if the first term is supposed to be 9, and in this case, if I plug in 1 here, if I plug in 1 for n, well, that's 15 times 1, that's 15 plus 9, that's 24. I don't want n, I don't want my first term to be 24. I want my first term to be 9. So I can start it. How could I make it so that it's 9 plus 0? And I'll leave it up to you. But, well, I guess it's kind of, we don't have to do that, actually. The question says, has she done it? We should say no, because she said it, but an explicit rule will have a formula that includes n, or n for the nth term. But that's all right. Number 6, that's pretty straightforward. I'm going to leave that up to you. You can read that, solve it. I think you got it. Explicit rule means, what are we going to do to the nth term? I don't like that n very much. N. What are we going to do to n? Are we going to times it by 5? Are we going to times it by 20? Are we going to say it's 15 plus n times 2? Or 15 plus 2n? Who knows? But I wouldn't probably use those numbers. I see the number 20 here, and you're going to notice at 0, it's at 45. That kind of tells us, kind of like up here, where 9 was kind of where we started from. Although that was the first term, not necessarily with the 0th term. So you can write formulas 2 ways. One, looking at the 0th term, or looking at the first term. We'll talk more about that. So you get to try seeing if you come up with a formula with that. Then we're going to look at number 7. 7, I'll give you a clue. If it was flat, if it was just a line, it's just kind of n is 1 dimension. If it's 2-dimensional, sometimes we call that n times n, or n squared, but this is a 3-dimensional figure, so it's write an explicit formula. So what are we going to do? N, right? Figure 1, each figure shows a cube made from smaller unit blocks. Write an explicit formula given the number of unit blocks. So you're going to need to count this, right? There's 1 block in figure 1, and if you notice, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 in this one. So what am I doing to 1 to get a 1? What am I doing to 2 to get an 8? And then what am I going to get 3? So what am I going to do for the nth cube? I'll let you try that on your own. And number 8 is a doozy. It's another one that I kind of want you to dive in. Don't want to do it all, but you're pretty sure you can do question A, right? And I'm pretty sure you can do question B. Question A won't take you long. You can draw it out. You can do however you want, for all I care. But I really want you to study, how do you see these shapes growing? You could easily start with counting. It goes like from 3, that's It's an 8. 4, 8, 12. Plus 3 is 15. That's 5, 10, 15, 20, 24. Do you see a pattern there? What would the 11th figure be? This one is not making us write a formula. But I bet you probably could find a pattern in those numbers. The first term is 3. The second term is 8. The third term is 15. Then 4. What would be the 11th? And I'll leave that one up to you. Not really going to grade this, obviously, for correctness. I was trying. Now, a lot of these up here, yeah, you better get it right because I kind of told you what to do. All you had to do is write what I was saying. But your job is to try your best on the rest. And because this is some really good thinking. This is good algebraic pattern thinking, which is exactly what Math 1 is, algebra. So we're going to call it good for now. You just holler if you need something. Peace.